to another video on number sequences. In this video we are going to find ways to find out the given sequence is a geometric sequence or not. A geometric sequence has a common ratio among the terms involved in that sequence. For example, the sequence 1, 3, 9, 27, the ratio between the terms are going to be same. For example, second term divided by first term is going to be 3. The third term divided by second time is going to be again 3. And the fourth term and the third term's ratio is found to be 3. Since the ratio between the different terms in the sequence is 3 or the same number, the sequence is considered as a geometric sequence. So in case of identifying a geometric sequence, we have to find the ratio between the terms. In the previous video of arithmetic sequence, we confirmed the sequence is arithmetic by finding the difference between the terms going to be the same, right? Okay, if you want to know about more about arithmetic sequence, you can check my videos on that topic. Now we will move on to the general formula for the nth term of an arithmetic sequence. It is given by an is equal to a times r n minus 1, where an is the nth term of the sequence, a is the first term of the sequence, and r is the common ratio. This is an explicit formula to find the nth term of the sequence. If you want to know the recursive formula, that is, whenever we know the value of the previous term and we want to find the value of the next term, we are going to use the recursive formula, which is going to be an, which is equal to a n minus 1 times r. Okay, an is the nth term and an minus 1 is the previous term. Okay, and r is going to be the ratio. So with this knowledge of the formula, we are moving to move into the problems. In this we have to find whether the given sequence is geometric or not. So the only step we need to do is we have to find the ratio and check whether the ratio is going to be the same between the terms. Then we can strongly say that it is a geometric sequence. Let's take the first example. 4 by 2 equals 2. The next two terms, when we take a ratio, is going to be again 2. So r is going to be consistent between the terms and the value is going to be 2. So this is a geometric sequence. Next is 10 divided by 2 is 5, and 50 divided by 10 is equal to 5. So the r is value is 5 and it is going to be consistent. So this is also a geometric sequence. Next is 6 divided by minus 12, which is equal to minus 1 by 2. Minus 3 by 6 is equal to minus 1 by 2. So the r's value is minus 1 by 2 and it is consistent. So this is also a geometric sequence. Next is 6 divided by 3 is 2, and 9 divided by 6 is not equivalent to 2, right? The ratio is different for different terms. So this is not a geometric sequence. Okay. Then 4.5 divided by 7, which is equal to 6.4 something, and then 2 divided by 4.5 is not equivalent to 6.4. right? So this is also not a geometric sequence because the ratios are different between the terms of the given sequence. This is going to be excluded from geometric sequence. So if we just check with the knowledge of arithmetic sequence what we did, the difference between the terms 3 plus 6 is 9 and 6 plus 3 is 9, sorry 3 plus 6, 3 is 6 and 6 plus 3 is 9. So the difference is consistent being plus 3. This is an arithmetic sequence. Okay, and let's check with this 7 and 4.5. The difference is minus 2.5 and the difference between 2 and 4.5 also is minus 2.55. So the difference between the terms in this particular sequence is going to be the same, that is minus 2.5. So this is also an example for arithmetic sequence. So far we have seen two types of sequences, arithmetic and geometric. There are many more other types also we will be seeing in the future videos. Okay, find R for the geometric progression where first three terms are 5, half and 1/20th. So R is nothing but we have to take the ratios. Okay, 1 by 2 by 5, right? The second term is half and we have to find a ratio between that and the first term, that is 5. So it's nothing but 5 by 1, right? So it is, we can write it like this. So it is found to be 1 by 10. Next is 1 by 20th by 1 by half. So it is going to be 1 by 20th times 2 by 1, which is going to be 1 by 10. So the ratio is found to be 1 by 10 for this particular geometric progression. Next, find the common ratio for the same thing, right? They have given the sequence. So second term by first term is equal to root 5. Third term by second term. This 5 can be also written as like this, right? So when we cut that, we found the value to be root 5. So the R's value is root 5 for this term. Okay, find R in each geometric sequence. Here see there is a digit missing in between and we have to find this. Okay, so minus 2 times R will give you the blank value, right? And that again multiplied by another R, you'll be getting the value of minus 8, right? So minus 2 and this blank digit, that is an R, and between the blank digit and the next digit there is an R. So if you multiply that, we will be getting the value of things. Okay, so R square is equal to minus 8 by minus 2, which is equal to 4. So R is equal to 2. If you remember, in case of arithmetic sequences, what we do is we add, see, first or any particular term plus 2d makes the third term, right? Like that we have a relationship. Here we are having this relationship in terms of ratio. So again there is one more example. So minus 1, there is a blank number in between, so there is going to be 2 R's, which is going to give the value of the next term in that sequence. So R square is equal to minus 4 by minus 1, that is 4, and value of R for this sequence is also going to be 2. And with this we will close the first video on this topic. We will be seeing further details about this geometric sequences in the future videos. So please watch, and if you like it, share with your friends. Please subscribe the video if you haven't done so far. Thank you for watching.